Hello everybody, Chris here, and in this video we're going to be moving the jump code from the base script on the character body 2D of Captain Clownnose up here into the idle and move states so that the character can jump from the ground and have that movement be controlled by the state machine, the Limbo HSM, instead. So as a natural kind of result of that, we're going to see that both idle and move are going to basically have the same duplicate code for everything. Being able to jump from idle or move, or later we might put in being able to do a ground attack from idle or move. And I think the result of that is that we'll see idle and move more as a combined ground state, rather than separating the code into both idle and move, if they both essentially do the same thing, minus playing the animation of idle or run. So we can combine this into a ground state and just have the ground state control if it's playing idle or move, depending on if the velocity is not 0. But let's go ahead and start first with moving the jump code over. So if we open up the character body 2D script, we'll see that jump is basically handled here as a import. So whenever player actions.jump, which is spacebar currently, is pressed and the character's on the floor, then we'll do a ground jump by setting the velocity one time to the negative jump velocity. So as per the previous video, we were handling our input and player input, so that's where we're going to want to start. So I will just copy this bit over to player input. So let's actually try this time using the import function so that we don't have to run that code on process for just waiting for the jump key to be pressed. So let's do function underscore, let's say, input, but instead of using base input, we'll use unhandled input, which means that if the space key event of jump is handled by something else in the UI first, we don't want two things to trigger. So unhandled input would mean that only if it hasn't been handled by something else that we actually run this input event on this code here. So this is the line we have copied over from the other script. I'll make that a little different. We'll say if event.isAction pressed, and we're going to need player actions.jump, which is already located up here, the resource which stores the string names for the action. Then we're going to set the jump variable to true. So let's create a jump variable, jump, which is a Boolean. So we'll say jump equals true. And then we can also say else if event.isAction released player actions.jump. Then we'll say jump equals false. So this means that as long as we're holding the spacebar down, the character is going to keep trying to jump, which for now is okay. We can always kind of modify this and tweak it a little later, but we'll start with that. And then we don't need this bit. The is on floor is actually going to come from basically being in the ground state already. So we might not even need to check is on floor, because if the character's in the ground state, then it's already implied that the character's on the floor. So let's cut that. We're not going to need it. And the last thing we need to do over here is to bind the jump variable to the variable on the blackboard. So just like up here, we're going to basically copy this, paste it down there. So we need a jump var, bbnames.jump var. And if I look up the old symbols, we'll just see that this is just a script that contains static variable names. So static var, jump var, the string name. What do we want jump to be referred to on the blackboard? So I'm just going to put in quotations, jump. And once again, the point of this script is just to be a globally accessible list of string names to share naming consistency across the game project. Basically, write the string out once and use the same name across all of our different scripts by referring to the variable rather than hard typing in the string. Okay, so let's go back to player input, I think it was. We have the jump var set. So this is the name of the variable on the blackboard. And we are binding it to this object, the player input. So we're going to need the property name here. So just copy that, go into here for the quotes, paste it in. And this last parameter is whether it will automatically create the variable or not. So I want that set to false. And actually to test that, I want to hit play and see if we get any errors when I hit space or anything. It's still jumping. I think that's because on the base script, we still have this bit. So I'm actually going to cut that out. of the root character body script, we can see that we're basically breaking apart this entire script into separate components. So in the end, this is just going to be basically a list of resources that are attached to the character. Okay, so let's check the errors. Blackboard can't bind the variable that doesn't exist. Yeah, okay, so that's kind of what we want to see, because we want to make sure that the Blackboard has everything we need. And in this case, it's just telling us that we've never created the variable. So on the Limbo HSM node, we have the Blackboard plan. We just need to hit manage, add a new variable, give it the same name as BBNames has, so jump. And then this is a Boolean. And for hint string, I'll say whether the character is trying to jump or not. And hit OK. And now we can hit play. We shouldn't get that error message. We can press space. We're not really going to see anything happening because we have nothing to trigger off of that Blackboard code. Okay, but the main error message has gone away. The other thing we're seeing here, these warnings, are just saying that we're not using delta, so we should underscore it to imply that it's not used for anything. So you can just add an underscore, go to the next script that it mentions, underscore that, and the third script, underscore it, hit clear, hit play, and that should be it. Okay, so now this should be setting the Blackboard property. So now on our idle or move state, or eventually ground state, we just need to read if jump is being pressed. And if so, then we need to actually make the character jump. So I'll jump into the move state script for now. Let's create a function jump. And this is going to take the character body, which on the character state script this is extending, is already set to character body 2D. And we're going to say that the velocity.y is going to be equal to negative. Let's see if we still have the stats. I'm going to right click on character state, character stats here, right? Okay. So back on move state, negative character stats dot jump speed or jump velocity. And that'll pretty much be it. Now, character stats doesn't have a jump velocity. If we look at the clown nose script, then we'll see player stats here is actually where jump velocity is being stored. So I think what we'll do, at least for this project, is just to say that every character can define a jump velocity, whether they'll use it or not. So we'll just move this up to character stats. We'll have jump velocity there and just paste that in there. So now we can grab this property in our move state, and it should be able to do negative character stats.jump velocity. To kind of confirm that, you can just move the property and then add it back in. So now that it's in the character stats, it's going to show up here. And that should work fine. So now we just need the condition for when we are going to jump. Okay, so to actually make the character jump, probably the quickest way to do that would be to do, let's say, if blackboard.getVar, we'll say bbnames.jumpVar. So just reusing the string name there. And this should be, let's just say that there is no default value. We expect there to be a false or a true set on the Blackboard. So if that is true, then we're going to run jump. Okay, so when we do this, this is actually going to run a whole bunch of times, I think. So let's hit play and try it out. So in move state, I'll hit space. But if I like hold the spacebar, you'll see that the character doesn't go down because we're allowing it to keep running jump as long as jump keeps being pressed. So there's a few different checks we could make on the character to ensure that it can actually jump still. We only want it to jump once off the ground. So we could say something like blackboard.setVar, and we're going to say ppnames.jumps, and this is going to be able to imply how many jumps have already been made since a reset. So let's get a value. Current jumps. Current jumps is going to be equal to blackboard.getVar bbnames.jumps var. And yeah, we expect that to be an integer. So we're going to set the new value to jumps plus 1. So if the character has 0 jumps, we're going to make it 1 jump. So let's jump into bbnames and just add that variable, static var. And we could give it something a little bit more descriptive. So maybe something like jumps made var. String name is going to be equal to jumps made. Just because jump and jumps are so close together that it might get kind of confusing, but this is more clear, I think. So we'll go back to the move state and change that property name to bbnames.jumpsMadeVar. Okay, so that will increase the jump counter by 1, essentially. So what we want to do is we want to make sure that the jumps counter is actually 0. So let's put in here, if the character is currently trying to jump, then we'll do the extra check. So if the character is trying to jump, let's check if the character has 0 jumps currently made. So let's try up here, making sure that the character is on the ground. So if character dot is on floor, it's just a convenient method of character body 2D. We can do that, and that's probably enough, but if we need to go extra, we could also add in and blackboard.getVar bbnames.jumpsMadeVar is equal to 0. So what this means is we haven't made any jumps, and the character is on the floor. Okay, so if we hit play and we move, well, let's see. We haven't actually added in the jumps made var. So that's a problem. Let's add that to the Blackboard plan. So add jumps made, and this will be a vector2. So obviously with this Blackboard plan, we could just have those individual states creating the needed variables on the Blackboard internally on the script. But I think having them typed out like this makes it a bit more visual and easy to understand like what is actually required for the character to run here. So that's kind of why I'm manually creating it rather than just setting true on the binding. Anyway, let's hit play again and move, and then we can get the jump. So let's see. Okay, and the jump's made, of course, that should be an integer, not a vector. So let's hit play, and I'll try to jump. So in move state, we can make that jump. But if I try to hit space again, it's not going to work because we don't have any reset on the jumps made here. So that would require some kind of landing scenario. And of course, we can put that into the move state or a ground state, but we see now that the code is kind of starting to pile up for the move state. So what I really want to do is just combine move and idle into one script. So let's say that in the players folder, we'll just right click, create a script here and call this ground state. And then basically all of this code I'm going to put over to ground state. This is going to extend character state up there at the top. Okay, and now, and so aside from that, it's just copy and pasted from what we had in ground state. Instead of dispatching an event, we're just going to handle the animations internally here. So I'm going to say when the character stops moving, character.sprite.play, and that's going to play the idle animation. So we can set a variable for that up here at the top. Export var idle anim, which is a string name, and we'll default that to idle, but obviously the actual name is idle s with a capital I and an S and a space in between. So I'll update that in the inspector. And then we need export var move animation, which is string name, and let's put in move there. So if the velocity is 0, we're going to play idle animation. Otherwise, we're going to play character.sprite.play move animation. Okay, and really, that right there is just combining idle and move into a single state now. So I'm going to take ground state, move this script up to move state. I'm going to rename this to be ground state. Let's just get rid of the idle state altogether. And because we combine them into one state, we can go up here to the HSM and we can remove these bindings. We are still going to use bindings in the project, of course, but not needed for the ground state because that handles both animations. So we're just going to put pass here for now. Still call it in ready, just so we're ready to actually use this again when we add in like air states and such. Okay, and let's see where we're at. So I'm going to hit play here. We can move. We can jump, so that's working, but the animation switching is not. So, okay, so as I mentioned, we have to get the animation names right. So in ground state, for me, and if I I can check the animated sprite to see this. It's idle S and run S. So ground state, I need to rename this to idle S and move S. Okay, if we hit play now, let's see, there is, oh wait, it's run S, sorry. So run S, and the default animation, actually, let's make that idle S, hit play. Okay, now we can see that we have one state, but it is going back and forth between idle and move. So one state handles two animations. Okay, so I think now we want to add in an air state so that when we are in the air, we can move around a little bit differently than we're on the ground. So first off, I'm going to take the move from character state and put that into ground state, because if I look up the symbol, this move is really running around on the ground. So I could just say movement for running on the ground when free to do so. Okay. And then I'm going to cut this and put it over there on the ground state. So this is really the ground move. Alternatively, you could put in a bunch of parameters like, okay, which variable are you actually using to determine how fast it moves in the air? But if you think that it's going to be different enough, you can just create a totally separate movement for air state. Okay, so let's create a new state in Limbo HSM, right-click Add Child Node, and I'll just type in state here. This is going to be a character state. Then I'll rename this with F2, air state, right-click, extend script to airstate.gd. By the way, while we're doing this, since I showed you kind of how idle and move state have just been superseded by this ground state, you can just take the idle state and the move state and delete those if you like. You can leave them there just in case you need to go back to them, but I'm pretty much sure I'm going to be done with it, so no need. So in the air state, just for right now, we'll just say that you can't move in the air. It's just going to basically move out however the velocity is going based on the character physics. That's it for right now, and then maybe we can add in an air move in a second. But let's go into the ground state and add in a transition from ground to air. So this is going to happen when the character is jumping or when the character falls off of basically the edge. So what we can do is actually take this is character on the floor, kind of move this out a bit. So if character's on the floor, then we'll allow it the option to jump. We'll still have those conditions there. But if the character is not on the floor, we want to immediately switch to the air state because it's in the air, of course. So we'll say else, and then we'll do a dispatch here. The event will be, we could call it like in air. Yeah, sure. And that's all we really need there. So we just need to take this event name to the state machine. We'll do the binding setup. So add transition, and we'll say states ground to states air, and the event is in air. We could also add in here another transition, which is going to be states air to states ground, which will be the event on ground, which we haven't set up yet, but we will soon. And I think the last thing we need to do there is to customize our states here. So in the Limbo HSM, we have this states dictionary. We need to edit these. So let's get rid of these two and add a new one. I'm going to say ground with the value of ground state, add key pair. That's our default state. And then we have the air state, which is going to assign the air state node. So add that in. And this will make it so that we can transition at least from ground to air for now. So if we hit play, we can see the characters in the air state, which is unexpected. So if the character's on the floor, we allow it to do this. Otherwise, we dispatch in air. So let's test if that's actually happening. Hit play. Okay, yeah, the character's being shown in the air. So let me see here. That could just be because at the initial starting frame, maybe it hasn't detected the floor yet. So let's also add in the transition for air state to ground, because it should be able to immediately switch back to ground. Okay, so in air state, we'll say function update. And if the character dot is on floor, then we're going to dispatch the on ground event. So let's see what happens with that. Okay, so let's hit play here. We can see dispatch in air is still occurring. Okay, so for the character body on that first frame, where we're checking is on floor, it just seems to not get that gravity collision yet, even though we're applying the gravity here and calling move and slide. So if that becomes a problem, we could just have a like a check, like if it's not on the first frame since entering, then we won't make the switch. Yeah, okay, why don't we just do that here? So var underscore on first frame equals true whenever we enter. We'll say on first frame equals true. And then down here, we only want to dispatch an error if we're not on the first frame. So else if on first frame, else if not on first frame, then we can dispatch. And then on exit, so we could do like function exit here, and then on first, oh wait, not on exit, sorry. At the end of our first frame, then we will say on first frame equals false. So that's kind of a workaround just on how the character body 2D seems to be handling that first collision, that first frame collision. So this first frame check here is just a lock to prevent switching to air before the character body has a chance to detect the first frame collision. So with that, we should not get dispatch air when we start on ground. Okay, and something we're going to have to be a little careful about when we're overriding the enter function here. We also have an enter function on the character state. So this bit about getting the character won't run unless we call the super function on the child state. So on ground state here, we want to call super here. So this means that we go up to character state and we run this code before we run the ground state's enter function here as well. So that's one of the things where you inherit too many classes on top of each other. It can get a little confusing because you might accidentally be ignoring one of the functions that's supposed to run. So be aware of that. If you need to call the parents function, use super. Okay, now if we hit play, we should be on ground state to start. If I hit space, we get the dispatch error because we're not on the first frame. We go to air. We're in air. Now physics isn't really running here because we need to be calling move and slide. I'm going to be doing character.move and slide. Eventually we'll turn that into the air movement. So let's hit space. We hit left click on the window, space to jump, and we have our jump added back in. Now we're not able to jump again, probably because we haven't reset the jump counter, but we were able to go from ground to air and back to ground, which is good. So on re-entering the ground state, or whenever we enter here, we actually want to set the jumps variable to 0. So we'll say blackboard.setVar bb.bbnames.jumpsMadeVar. And we're going to set that to 0 whenever we enter. So we hit play, we click on the window, jump, we go to ground, we can jump. And as you can see, based on the direction that I'm traveling when I leave the ground state, it's going to keep moving in that direction. It's just applying the gravity, and that's really it. Now, if you actually make a character like this, I mean, you can do it, but you're going to have a lot of going off the cliffs and not being able to backtrack or do anything about that, which is, you know, pretty realistic, I guess, in a sense, but really hard to control in terms of game mechanics. So what you might want to do is go back into your air state, and we'll take this move and slide and we'll do a air move. So function air move, character move and slide, we'll paste that in there. And then we need like a air speed. Probably you want that to be different than the run speed. So let's look up character stats in our scripts. I'll go into character stats, we'll add in here export var airspeed. And let's make that default to something probably slower, like 150, maybe. We'll see how that works. I'm probably going to need to turn this into like an acceleration, not just setting the value. So let's go back to ground state. We'll go down here. We'll grab this bit back to air state for the air move. And let's paste that in there. So the air move, we're going to get the direction based on the user input. And if it's not 0, then we're going to set the velocity equal to that. But that's going to be basically whatever the airspeed is, it immediately becomes the airspeed. So there's no acceleration or deceleration. Or I guess here's deceleration of a sense. But it's going to require some tweaking to get this to work. So first off, change character stats.runSpeed to airspeed so that we're working on a different variable there. And if we want, we can return the speed or the velocity. So we'll say return character.velocity here if we like. And let's hit play and see how that's working. So we get into the air, and you can see we can move in the air. But if we jump into the air, you also see that it immediately stops whatever movement we had from the ground, which is kind of wonky. So actually, if the direction is 0, I don't want it to move towards 0. There shouldn't be any friction. So I'll cut that out and save, and let's go run. So I'll jump, and now you'll see that when we don't press anything, we're just basically using the last input in order to determine which direction we move. We can change it so that we do have that air move, but it's immediately slowing us down from the ground run speed into our air speed, which isn't exactly what we want. So in character stats, we'll also want like a export var air acceleration, which would be a float. Let's just set it to 100 for now. Okay, and I'm going to start by getting the current velocity here. So var velocity equals character.velocity. We'll just get the current velocity. So our current velocity is equal to that. So we only want to decelerate if the direction we're trying to go is the opposite of the current velocity. So for instance, if the character is already moving, let's say velocity of 300 to the right, we don't want to slow it down to 150 to the right if we are pressing the right input. Okay, so if the direction is greater than 0, then we're trying to move to the right. Then we'll say the character.velocity.x is going to be equal to the maximum between these two numbers. So the current velocity.x and something like an attempted velocity. So var attempted velocity is going to be equal to the character.velocity.x plus character stats.air acceleration, but that's going to be the min of the airspeed or whatever this becomes. So let's see, min character stats.airspeed and this. Okay, so let me explain here. Okay, and this should be direction.x up there. Okay, so if the direction x is moving to the right. Okay, so we want the lower of two values, hence the min function, of the airspeed. That's our airspeed cap speed when we're trying to move to the airspeed. That's as fast as we can go when our character is accelerating in the air, so to speak. And we are taking the velocity x, the current velocity. Yeah, and that should be like this up here. Yeah, you know what? Actually saying current velocity is kind of redundant. Let's remove that bit right there and just say character.velocity.x. And down here as well. Right. Okay, so this value is taking the acceleration and adding it to the current velocity, right? But our acceleration is capped out by our max airspeed. We could actually rename this to be max airspeed. That might help a little bit. So I'll right-click, look up the symbol or character stats. Let's say max airspeed. Okay, now we'll go back to the air state, and it's going to give us some errors. So we rename character stats.airspeed to max airspeed. Okay, so this is our cap, and this is how much we're trying to accelerate to before applying the cap. So we apply the cap with the min function, and that's our attempted velocity x. So there from there, we're going to put this into here, and let me add some comments to kind of help this. So this is the acceleration capped by max airspeed, and this is taking the higher of the current value or the attempted velocity x. So if we launch our character into the air, and it's already traveling faster than our max airspeed, then we're going to keep going at that current value. So we can slow down the character to a lower value, and we can control the character manually between the max airspeed and negative max airspeed. But if we are launched at a super high speed, then we are only going to be able to decelerate from that very high speed. Yeah, hopefully that kind of makes some sense. And we may have to tweak this, but let's see. Is there a way we can do positive and negative in one go here? Not off the top of my head. So I will say, else if the direction.x is less than 0, then we're just going to take this and invert it. Okay, so this is going to be the max, and then this is going to be the min. Okay, because here we're looking for a number closer to 0, and then here we're looking for one that's further away from 0 to the negative. Okay, so the attempted velocity x, we're going to subtract the air acceleration here instead of adding it. And this is going to be actually the negative max airspeed. I could say -1 times if that makes it a little more clear. And down here we have the attempted velocity x. So if the current velocity is lower, as in to the left, more negative, than the attempted velocity x, then we're going to take that. Okay, and then I think we don't need this bit right here. And this would be acceleration / deceleration hit by max airspeed. Okay. Yeah, hopefully that roughly makes sense. So let me hit play, and I'll give it a shot. We'll jump into the air. Okay, so you can see that when we have that fast speed, we are still maintaining it. So I can slow down by going to the left, but if I keep pressing to the right, I'm not actually making it go faster than it already is, but I'm also not making it go slower. So when I'm going very fast to the right, I can only decelerate by pushing to the left, and vice versa. So if I go very fast to the left and I press right, I'll decelerate, but I'm not going to ever get back to those very high speeds of the ground launch, so to speak. So that's one way you can set up your character. I'm kind of surprised that pretty much worked in one go. So now you would just want to tweak your values. So we could change the defaults here. Maybe it's like 200 for the max airspeed. And we could say the acceleration is maybe faster too. We could say like 200. So now it'll look more like this. If you want, you could also add back in kind of the natural move towards 0 air friction of some kind. But that might be making it more complicated than it needs to be here. Okay, so our jumping's pretty much working. Our return to ground state is working. We could have like a landing animation if we wanted here as well. That is very much character dependent if you need that sort of thing. Last thing I want to do for this video is to put a facing direction kind of node so that we can flip our animated sprite depending on if we are facing to the left or the right. So I'm going to right click here, add a child node. Let's do a node 2D. I'll move that up here. I'm going to rename this to be facing. So I'll right click, add a script. This can go in character actually, because all characters should basically be able to face a direction. Let's create, and I'll rename this class name facing. And what I am going to want to do is on physics process, let's say, then we'll update the facing direction. And in this case, that's going to be the scale. So a scale of -1x is going to be facing to the left. And that's specifically scale.x. So on physics process, we are going to get the velocity. So if character.velocity.x is greater than 0, then we are going to take the scale.x and set that to 1.0. Else if the character.velocity.x is less than 0, then we're going to take the scale and set it to -1.0. Oh, and we need a reference to the character script or the character body. So let's do a export var character body 2D. Okay, and we assign it in the inspector, Captain Clownnose, and that's basically going to be that. Oh, and for this to work, you actually need to take the nodes which need to be flipped and put them under facings. So that's going to be the animated sprite. I'll pop that in here, and we can hit play. So now if I do left-right, we have left-right movement because we're flipping the scale on the parent node of facing. And that is how you can make a character play one animation, but flip the node so it looks like it's playing it to the left when really it's just playing the same animation, but the node's flipped around. So that is a pretty thorough explanation of ground and air states, switching into jump modes, also adding in air acceleration and deceleration, which I didn't plan to go that in depth for it today, but hopefully, yeah, that bit of this code here about air acceleration and deceleration helps you guys out for creating a cool platformer character. So I guess the next video before we jump into the Limbo AI for the enemy with the behavior tree is going to be to do a couple attacks on the character. So we'll add in like maybe a ground attack, and if there's an air attack, let me check if there is. Do we have an air throw or air swing? Yeah, okay, actually he does have that. It's cool. So we can add in like a ground attack state and an air attack state where it'll play those animations, and we can have them hit the enemies as needed. Okay, so that's going to be it for this video. I've been Chris. Once again, the project files are in the description if you want to check out the Ko-Fi and Patreon for supporters. Thanks for watching to the end, and I will see you in my future video content.